Okay, so I think we can start. Yeah, so good evening all, and welcome to this CS Katha Barta talk. Today's speaker is Dr. Nidhi Tiwari, Principal Applied Scientist from Microsoft Research. So Dr. Tiwari is a highly experienced software professional with a strong background in research and development, specifically in performance modeling and artificial intelligence. She has expertise in ideating and implementing software solutions for diverse domains such as banking, logistics, and enterprise products. She holds a PhD in computer science with a focus on distributed computing and ML. Dr. Tiwari is actively involved in interdisciplinary collaborations, contributions, and publications to enable advancements in performance modeling, energy efficiency, and AI. She is also skilled in mentoring and guiding students for AI research projects. She is interested in enabling and inspiring the next generation using the experience and expertise. So now, without any further ado, I would like to invite Dr. Tiwari to begin with the talk. I think you're muted. Is it? Um,
You're still muted.
yeah, I think is it? Yeah, yes, I think it's still muted.
Nidhi, you are muted. Yeah.
Okay, can you hear
Okay.
me now?
Yes.
Yeah.
Yes.
Okay, and my screen,
Your screen is visible.
and it's only one now, right? So you can see the presentation mode.
Yes, just the slide that you're presenting.
Okay, and it's in presentation mode. Sorry, I'm just confirming.
Yes. Yes.
So thank you for the invitation and the nice introduction. Really happy to be here. Like my introduction says, I'm very interested in mentoring and encouraging folks to learn new things and leverage them. So today's topic is on the same lines that how we can effectively use large language models. And the focus for today's talk is, of course, that open source models. Because we all have been looking at a lot of use cases and demos of large language models. So how we can leverage them for different applications. So this is just a very high level overview of them, and then how we can use them. So the agenda for today's, though we all are aware of the importance, but for this sake of flow, I will start with the motivation, provide overview of the foundation models, and then look at some of the ways like how we can use LLMs. So LLMs are being talked of as OS today. So how we have operating systems, LLMs are being kind of looked at, that how they can be used in each and every application going forward. So if we have to do that, that is the future, then what are the things that we need to keep in mind? So some of them I'm trying to cover here: model selection, how do we go about doing it, then prompting strategies, when it comes to like we have to use them, then what are the different techniques that we can use them, make use of if we want to leverage their capabilities, and then give a high level overview of what is llama, which is which kicked off the open source fight, or the landscape. It opened up the landscape for open source large language models. And then one example of a smaller large language model, which is alpaca, then demonstrate like one of the way of using LLM into a small mobile app also that can be leveraged and used. So the focus is like how do we leverage them and use them for different applications and improve the productivity. So we have seen like now the language models are not, they are not called language models, but they are like available for generating code. So you tell them that this is what I want my code to do, and they would be able to write code for you in different languages, so that you don't have to spend a lot of time in writing the code, but you will have to review it. Then we are seeing how these foundational models, image foundation models to be very precise, are being used for generating images. So definitely a lot of marketing apps, and those apps are using it to generate very beautiful pictures or even stories using these foundation models. Then Microsoft is having a big time into this, having co-pilots for, say, generating PPTs, for generating Word docs, processing different Excels, so that you can do things very quickly. Then, of course, coming to a small joke, that today, especially in India, even being it available on mobile, so we have this Chat GPT which is available on mobile. So even a small vendor like for chai would know about that GPT. So we definitely need to know and leverage GPT for different use cases. So let's talk a little bit technical now. So the generative AI. So today, what we are seeing, the foundation models, they are the starting of the generation. Like, they can generate the data. So the foundation models that are used are mainly, we can think of them as three domains. One is in language. Then we have foundation models for vision, and then code. So the examples are definitely GPT-3, GPT-4, ChatGPT, which are trained on language data. Then for vision, we have DALI as very popular model, which is being used for generating images. And for example, GitHub Copilot is there, which is using something like Codex or other models for generating code. Now, let's see how these foundation models evolved. So when we look at machine learning, it has been a thing from last 10 to 15 years, where we had these models which would have some input and then be trained to generate a given output. So we would have a separate model for, say, sentiment classification. So we would train a machine learning model for doing happy, sad, that kind of sentiment generation. Then entity tagging. So if you have a document, how do you extract the named entities, for example, name of the organization or something. So for each of this scenario, we would have a separate model, and it would be designed and trained and then used for that particular use case. So it was very much use case specific model that was developed. Then next came the large language models, which were more like unsupervised models. So here we were not training it for a particular use case like sentiment classification or something. We were just providing it lot of text, especially when we are talking about NLP, lot of text from internet, so that it could model the language as to how the language works. So it was pretty much like unsupervised learning, where we were not telling it that for this input this should be the output, but the data was provided to it, and internally some the objectives were defined so that it could understand how the language works. So they were called language modeling understanding models as well. So we used to train one model and then adapt it for each of the use case, which used to be called like fine tuning of this large language model. So the advantage from this previous approach was that the less amount of data was needed to fine tune it for each of these use cases. So now the next thing came up was prompting. Now we have these huge, very, very big models in terms of the number of parameters, and also in terms of the amount of data which is used to train these models. They were still trained with, unsupervised manner, but the size of these models is huge, and the data used for them is huge. That's where they have started doing these kind of tasks just based on prompting. So now we don't even need to provide some kind of fine tuning to these models, but they can, based on the instructions that we give, they would be able to perform some of these tasks without fine tuning. So that's where prompting techniques are something that we are evolving today to use these language models. So now, how this unsupervised pre-training is done. So here, it is like you have these text, and then it is hidden. So the output, the last word, for example, would be hidden, and then the model would be asked to predict the last word, and then it would be trained until the loss is less, and it is able to predict the last word accurately. So this is one way of doing supervised, unsupervised pre-training of these large language models. Other method is masking technique, where intermediate words are masked, and then LLM is trained to predict that intermediate word. So T5 or BERT, Roberta, these are some of the models which are trained using masking technique. So now there are many technical things about these models, that you would have encoder, decoder, and some of them would be, so encoder would be used to reduce the size of the text, and then decoder would be used to again generate the output based on that reduced text. So there are different types of models that exist, and we will see, like, GPT-3, for example, is just decoder. So the generative models are usually mainly decoder based, and the models that we are today using, like Llama or GPT-4, most of them are just decoder only models. So now what is happening is, like, why we are able to see that emergence, which is like without even providing any fine tune or any example initially, the models are able to perform. So some studies have been done where they observe that as the model size is increasing, they are becoming more emergent. That is, the capabilities are increasing. So they are able to do summarization, they are able to do arithmetic operations and logical operations without much of fine tuning. So the key thing here has been like the size of the model and the amount of data used for training these large language models. Now, next thing come today is, like, when we are using Chat GPT, it's next level of fine tuning that has been done, so that we can talk to it. It acts like a assistant for us. So we had supervised fine tuning initially. So the way it was done was, you pre-train the model, like we saw we do unsupervised pre-training, and then we do supervised fine training. So fine tuning, where we provide that for this question this should be the answer, and then so the way it is provided is, it should be in this tone. For example, when I'm asking question, it should be in this tone, and this should be the output, the way it should be formatted or something. So that is first level of fine tuning that is done. Then next level is, you have a human in a loop, where human rates the output, that this output is good or not good, and that is used as a reward to create a reward model, and that reward model is then used to fine tune the chat language model. So this is how we see that, because now why humans are being used to, for example, to reduce the toxicity, or to reduce the bias in the answer, or further improve the tone of the response. So those are make it more secure or safe to use. So one reason of having this human in the loop for training is the safety of the language model, so that when we are interacting with them while chatting, it is more safe and secure to use them. So this is how the RLHF works, and they help in tuning the LLMs for acting as an assistant or as a chat model, where it knows that this is a question, so I have to answer it like this. So that is what is RLHF training. And these are some of the data sets that were used for doing this training for ChatGPT. Now, some of the new use cases, or like we saw the emergence that has been seen because of this RLHF, is like summarization. It is able to do the abstractive summarization on its own. Then, if you have a recipe, it would be able to give you a shopping list. And then multilingual generation. So just one model would be able to do both. It would generate as well as translate. So if you ask question in one language and ask it to reply in another language, it is able to do. So these are some of the emergent capabilities, new capabilities which these models have shown. They are able to do reasoning problems, they are able to solve it. Arithmetic problems also they are able to solve. There are definitely few things that need to be taken care, which we will go through if we want to get good output or accurate output from these models, so that we will see. But they have this capability and we can leverage them for doing or doing this kind of problem solving. Now let's come to the next topic, which is like, if I want to create application, which is say assistant for doing any of the job, or writing a co-pilot to help me with some of the tasks that I do day to day or anything else, then how do we go about using these LLMs? So definitely, with so many LLMs today, how do we select them? So even for OpenAI, they have some 3 to 4 which are available for use today. Other than that, then you see like Microsoft has come up with its own model, Google has come up with models. So how do we select them? So the best model for the use case, definitely there will be trade-offs. So we would have to definitely do an evaluation to see the quality of the model on your task specifically. So it could be a question answering task, or code understanding task. Then what is the speed? So is it a real time use case where you want the speed to be real time, it should not be delayed. Then cost is definitely one of the factor which we need to take in picture, especially when it looks like small. They definitely say that it's 0.004 cents or something, but it is per token. So the cost calculation should be there based on the scale at which we want to use it. So the use case, what is the scale of the use case, and then come up with the cost calculation. Another thing that we need to consider is fine tunability or extensibility. So most of them, like we saw, they are just pre-trained on large data. Now if that data is out of domain, or your data is something very specific, say or a particular industry, then will it work, or you need to fine tune it. Then if it is possible to fine tune it or not, so those things need to be considered. Of course, data security and license. So a lot of time we don't know how our data will be used when we send it on cloud or something. And if we want to be sure that that the data doesn't leave our premise, then we will have to think about the other things of using these large language models. That is where the OpenAI or any other these proprietary models which are hosted by this company will have some of these limitations of cost, scalability with definitely cost. Those two are related, right? So the as the volume increases, the cost will may go up. And then accessibility, so how easy it is to access, and the data security aspects, and the specifications like fine tunability and other things. The data used for training those models, so mostly we are not aware of the data used, what is the architecture of those models. So under those circumstances or those scenarios, definitely open source like large language models are coming in handy, which are being released by different organizations. So the good part is they are trained on large volume of data, so they have been trained for a lot of them would be trained for a few days on large GPUs, and we have those pre-trained models available on something like Hugging Face is providing a lot of models with, and even hosting them, where we can go and even play with them, try them out, and then see how they perform on our specific use case. So other than that, now how do we compare them? So there are a lot of benchmarks. One of them is from Stanford. The other one is from I think Google, which is Big Bench, and a lot of them are there on the Hugging Face also. So the LMSys is one which compares chat models, and those leaderboards can be used as a reference to find out which model is performing good on which data set. Now, these benchmarks are basically like the data sets or the task. So for each task, a data set is defined simply if you see the sentiment classification. So there are certain data sets which are part of these benchmarks for sentiment classification. So you can actually go and see the model performance on sentiment classification, or truthfulness is one metric, that how good this particular model is performing on a given data. So it should not be like so one of the biggest problem with the large language models is hallucination, because they have seen so much of data and it's all the probabilities based models, right? So the model knows only the probability of the words, so it starts hallucinating. So how do we use them for a given domain data or something? So truthfulness is one of the metric to measure that it is sticking to the correct facts and giving me the correct answer. So like that, you can find multiple data sets and metrics on these leaderboards, and then use them as a reference for initial large language model selection. Now, how do we access these large language models? So as we know, one of the ways to call the OpenAI API. So they have hosted them, and we can get a, we'll have to buy some subscription, get the key, and then provide that key and use them in the API calls. Similarly, like I said, Hugging Face has also hosted some of these open source models. We can get a key from Hugging Face. Once we log into Hugging Face, we can create a key and use that for accessing this. Otherwise, we can even download them and use them through Hugging Face transformer libraries. And other than these, of course, we have other models which can be accessed through Spacey and Gensim, for example, for embedding. So we will have to convert our text into numbers for sending to large language models, or making them process that. So some of these older libraries and models can also be used. So Spacey, Gensim, they can be leveraged for doing those tasks. So another limitation for using LLMs becomes stateless. So they don't store any data from even from one call to another call. Though if we are chatting with it, it looks like it remembers my previous conversation, but it's not the model. It's the app which is built around that model. So large language model by itself will not remember the past conversation or the past input. It only remembers the current input. And the other limitation is the size of the input is limited. So if you see 16K model, that means these are really new models which are having a context length of 16K. But most of the time you will find that that is also not enough for the task in hand. So it becomes a limitation. So how do we create the apps which use these LLMs which are stateless and which have limited context length? So these frameworks are evolving at a very rapid pace. So LangChain, semantic kernel, then MLC LLM, and one which I'm using right now is called Llama Index. So these frameworks are providing very easy way to kind of create the apps which will they provide the way to store the states and or maybe index them, for example, to get over the context length limitation. So these are some of the examples of the programming frameworks that can be used to create the apps using these large language models. Then design options. So we will see some of these design options as to how do we, access them in our app. So one of them is RAG, which is retrieval assisted generation, and model fine tuning, which is similar to supervised fine tuning that we used to do for previous large language models. So, like I was saying, one of the go-to place for open source models today is Hugging Face, and it provides you the open source library to create models, to access them, to fine tune them, and then, like I said, it is also helping with operationalization, because you can host your models. So even once you fine tune, you can host your models there and make it available for say you accessing through APIs to in apps and all. And of course, they have a good community for solving and discussing the problems that you might be facing while creating the apps. So yeah, it has a lot of resources for getting started. Another thing is that we need to think of is the size of these large language models. So they are huge. So if we want to use GPT-4 or GPT 3.5, then we would need a huge server to even host it or deploy it and all. So we need something which is smaller, and that's where now the newer models are, coming, which are smaller in size and trained using very selected data set, so that their performance is still good. So some of the examples are Vicuna, Red Pajama. Now the newest one are Phi 2 from Microsoft, for example, which is just 2.7 million parameters. So that way now the smaller models are coming out. They are fine. They are basically pre-trained from some of the large language model data. So we will see that example. The other way to reduce the size of large language models, which is the one which was being used before this whole chat GPT wave started, was model distillation, where you could have, for example, a teacher model which is huge. You can use its output to train a smaller model which is like a distilled model. And the other technique to reduce the size is model compression, where you have an existing model and you can compress it to a smaller size using some of the techniques like lottery ticket, which Professor um, Mishra and I am working on. So that is another technique to compress the large models. And then now the libraries are coming up which help to compile them. So one of the library which we tried was MLC, which can help in compiling the large model into smaller size and making it actually like a native thing for running on, say, mobile, so that its size is smaller and it runs natively on, say, Android or iOS. So you actually compile it for a particular OS so that it runs natively and is smaller in size. So yeah, these are some of the things. The idea of this is just to make you aware that what are the things that you need to do when you want to create applications using LLMs. So one of the technique of model compression is called quantization technique, which is very popular, and you have libraries which provide you this capability. It actually reduces the precision of the weights, so that's how it manages to reduce the size. So basically, the decimal places or the number of bytes used to store weights of the model is reduced. And because it is more of a technique, it does it without impacting the accuracy. And there are different ways to do it. One is, of course, post training. So you have the model which is pre-trained with available and all. You can compress it using these post training model compression techniques, and you can also do it using during the training. So where you train it, this is called quantization aware training. So the weights are actually stored in lower with lower precision during the training itself. Like I was saying, MLC LLM, this is another library which is mainly for compiling the models into native form for deployment on different devices. Now let's come to the next aspect of using the large language model. So we saw that we have to select a model, then maybe we have to make it compatible for our deployment, where we want to deploy it. So we need to make it compatible. Now we saw that how we can call it using APIs and all. Now how do we program them to do what we want to do? So the next thing is, now we know that it's a generic model and it can do whatever we ask it to do. Suppose, I mean, it may not be exactly correct, but the best of the thing is it can do what we ask it to do. So how do we tell it that I want to do this and make sure that it does it correctly? So some of the techniques that are commonly used are prompting. So like we said, we prompted. Prompt is basically an instruction which tells a large language model that this is what the task is, and this is how you do it, and this is how you provide me the output. So there are some techniques, or we call it prompt tuning, that can be done. uh, then for next level is few shot. So when we were calling it large language model, we can give some examples that, see, for this text, this is the sentiment, and for this text, this is the sentiment, and now you know what to do and how to do, because we have given you examples. You should be able to learn from those examples. Again, that is part of the emergence in these large language models, that they are able to learn from these few shots also. Now, for a given task, you may have lot of examples, but lot of times what will happen is you may have to do dynamic example selection. For a given input, find a matching example, so that the model knows that, okay, for this type of input, this example is good, and this is how I have to provide the output. So we may have to do prompt design based on the input using dynamic example selection. Then other way is retrieval assisted generation. Now, as we know that context length is limited, we can't provide all the data, all the documents. So if I want to create a FAQ for my, code base or wiki, I can provide the whole wiki data into the prompt, saying that this is the data. Please tell me what is the answer for this question. So that is where retrieval assisted generation is used. We will see how we do this. And the next level is fine tuning. Now, these two can be done, these are complementary, they can be done in parallel, or they can even be done together to get even better answers. Now, as we see that here, complexity, cost, and impact both will increase when we go from one technique to next technique. So if we do zero shot prompting, basically we don't give it example, it is the least costly, because my prompt size is small and I don't have to do any preparation for it, and so it is least costly, but we may not get the correct answer all the time. That's why we want to give some examples. Now the prompt size will increase and the cost will increase, but it may give us better answers. Next comes retrieval assisted. Now we need to do a lot of background preparation for this to do this. The prompt size may not increase that much, but the cost of indexing it and doing the background preparation, it will be complex. So that cost will be involved. Similarly, fine tuning, we need to do a lot of background work and preparation, but the impact, the output would be much better than zero shot. So next level is like reinforcement learning, from human feedback, the thing that we saw for ChatGPT. Now it is really complex, and if you want a human in the loop, it will be very costly. So that's where, if you see, and training from scratch is definitely super costly, and I don't think a lot of people are thinking of this currently. So yeah, this is how we see that problems that they can kind of address is that the form of the problem and the factual problem. So if we want more factual things, then again we want to go for something like retrieval assistant and fine tuning, so that more factual answers can be answered. So let's see in detail what these techniques are, like how they work. So prompt engineering is the basic thing which is used for using the LLMs. So prompts are the mechanisms to interface with large language models. Prompts consist of task definition. So now prompts are the input and they are the interface. They need to be really clear. If the question is not clear, then the answer will be wrong. So that's where prompts need to be designed carefully. So you need to have a clear definition of the task. Like I said, few shots examples. So you give some examples of this, for this input, this should be the output, and how this output was derived. So if you give that, then model will also know how to work on the input to get the desired output. And then the overall thing, that is the task definition, this all constitutes the um, input to the model. So prompt engineering is now one of the thing which is evolving, like software engineering. We had, like we are saying, OS of today is LLM. So that's where prompt engineering is evolving to use this LLM or the OS. So it is the way how we design the question so that we get the right response. So let's look at some of the prompting strategies. So we saw that zero shot is something where we don't give any example, we just give a question. We give that this is the context. So here, if you see a juggler can juggle 16 balls, this is the context. Now the question is how many blue golf balls are there? So this is like zero shot. I'm just giving the context and asking the question. Then we have few shot where we give some example. So one shot is we give one example, two shot is we give two. So here one basically example is given, so it is one shot. And then comes the newer techniques which are called chain of thought. So this is one of the most popular and effective technique that is being used today, where zero shot COT is you give the context, you ask the question, and just add this one small sentence saying, let's think step by step. Now, what this does is it helps the model to break down the things, come up with the steps, and then follow those steps and then get the answer. Now, if it is slightly complex problem, then next approach is that you can actually give few shots or the examples that this is how you need to come up with the steps. So if this is the question, these are the steps, and this is how the answer is derived. And then you ask a new question. So for the new question, you give the context and then ask, and then the output is even better. So depending on the type of the question or the task, you can go for, if it is a simple task and you know that it would be able to perform. So a lot of times even translation, sentiment classification, these simple things, it is able to do with zero shot also. Then if it is slightly, some kind of classification problem which is use case based, you can use few shot, give it some examples that these are the classes I want, this is the example of this class, and give it as few shot, it would be able to do. For more like reasoning problems and mathematical problems, zero shot COT or few shot COT, that is chain of thought, are recommended. Another technique which is used today for automating lot of tasks. So when you have multiple things to do, where say I want an answer from some data. So and then for getting the data, I need to do some search. So there is some tool that needs to be used in between. Output of the tool needs to go as input to the next question to the model. So the steps. So basically, it will break the steps. Now for each step, either it has to go and use a tool to perform that step, and then output of that tool will go to the next step. So if we want to do something like this, then this kind of prompting strategy, which is called React, this has become very popular, especially for creating some of these assistants to automate certain task flow or the workflow for doing this. So for example, create a report for me from my these last three reports in during the semester. I want to create a final report. It should have these things. So for each of the thing, it may have to go and search the report, get the output from the report, and then feed it to the final report. So this is where React or Reason plus Act kind of prompting strategy is used. So if you see here, the prompt will consist of the instruction that solve a question, um, answering a task with React steps, that interleaving the thought, action steps, and then you give some examples. So for this reason, these are the actions that should be taken. And next steps, like what is the output from this action that should go to the next step. So if once you give some of the examples that for this thought, act like this is the observation, then come up with the next thought. For this is the action that you need to perform. For this thought is basically the step, like we were seeing, right? Step by step. So for doing this, what is the tool you need to do? And so this is, it goes in a little bit of loop. So that is, these are some of the techniques which show that how these emergent large language models are really capable of doing, multiple things, follow multiple instructions and all. So yeah. Now let's come to the next complexity level for using the large language models and more grounded. So the um, retrieval augmented generation is used for getting the outputs which are more grounded and fact based. And of course, we saw the other reason for using RAG is context length also, and domain specific data. So if we have more domain specific data, that probably model would have not seen, and we want it to have this in the context of the model while it is generating the output, then we use retrieval augmented generation. Now how this works is, first thing is we have to prepare this data set where we have our documents. For example, wiki data set is there, we have a lot of wiki for say songs. Now we get that data, we chunk them into smaller pieces, and then create embeddings and store them in the embedding vector, and we have the reference links for accessing these vectors. Now, what in the real time when we are using the large language models, we have a query coming to the large language model. We will create an embedding of that particular query, find the closest vector in this database which is matching to that query, give it to the large language model to synthesize the response. Now, this is just the text. So we get the text for that vector and send the query and that context which we have retrieved. So it could be one particular, wiki, not all the wikis that it has retrieved. So give me a Kishore Kumar song. So for example, that. Now here we had all the singers' songs listed, but now because my query wants Kishore Kumar song, so it will search in this for Kishore Kumar and get the wikis related to Kishore Kumar songs, for example, and provide it as input to the LLM. LLM would be able to then synthesize a response saying that this is the list of songs sung by Kishore Kumar, for example, and provide the answer. So this is a good way to introduce your domain data, increase the context length, and make it more factual or truthful to the given question. So now, like I said, it is going to give you better results than zero shot prompting or few shot prompting. And the large volume of data that we wanted to look at is also kind of uh, provided to it without increasing the context length. Now, when we use this, again, we'll have to see which kind of this vector matching metric we want to use, what is the vector database that we want to use, kind of algorithm we want to use for matching them. So these things need to be again taken care of when we are designing a RAG. Okay, so next complexity level is model fine tuning, but definitely has a higher impact, um, where you need to go for fine tuning when you have large volume of domain specific data. And few shot prompting just enables in context learning, and you would not be able to provide all the data in that smaller context. And then of course, other reason to go for it is it's hard to describe, actually in words, that this is what I want to do. For example, this is how I want it to be formatted. It should be written in this specific tone, or those kind of things which are more um, artistic, or those kind of things. Then also you may have to go for fine tuning. And of course, to save the token. So if every time you are, like I said, it's stateless. So the large language models are stateless. If we invoke them, we have to give the context every time in that limited thing. And the more tokens we give as input, the higher the cost. So if we fine tune it, then definitely we save on that bigger context. We don't need to send that every time. So we save on the cost. And definitely it is faster once it is fine tuned. Then we don't, if we as compared to say RAG. We don't have to go through the RAG search and all. It will be much faster and cheaper and give you a better quality. So these are some of the points when you should think of going for model fine tuning. Now, some of the ways you should go for mostly tuning the smaller models, and you should have a significant amount of data. It may not be, in terms of tens of thousands of hundreds of thousands, but even if it is in few hundreds, fine tuning is recommended. And these some of the techniques are like low rank adaptation techniques. So these are some of the techniques. The most popular one, which is used today for fine tuning the models, is PEFT, or which is called low rank adaptation, where it is the number of parameters that you tune. You don't tune all the parameters of the model, but you selectively fine tune some of the parameters. And if we look at LoRa, it actually tunes additional parameters which are smaller in number, and then helps you to get better answers. I will not go in detail. I don't think we have that time. So the library that is available for that is again from Hugging Face. Library is available, which is called PEFT library, which provides you implementation of different fine tuning algorithms. And so the most popular one, which is LoRa, is also available there. Now, one of the most popular open source model is Llama 2. So Llama 2 is collection of these different large language models ranging from size 7 billion to 65 billion parameters. And in their paper, they report that it outperforms the models which are few, 10 times or larger than Llama 2, for example. So with the smaller size, they are able to get better performance. And the reason is the large amount of data that was used to train pre-train Llama, and the selective data set that was used to train this Llama model. Then next comes the example of the smaller model, which was, the alpaca, which was trained by Stanford. So the example here is to show that the cost can be very small and still you can have a very fine-tuned language model for your own task. So this is the most common approach today, if you see, to get a language model for your own task. So you have the large language model, you fine tune it using supervised fine tuning for your task, and it performs at par with the models which are 10 to 15 or even 50 times your current model. So the task at hand, it can perform really well with smaller data size, fine tuning, with lesser resources at lesser price, and private. You can run them in your own private, and it is less costly when you run it. So some of the points to ponder is like output quality depends on the foundation model that you're using, the data for sure, because garbage in, garbage out, and the prompt. So especially for data, if you see one of the model 5.2 which was released was basically trained on very much filtered data set, and it was shown that it is performing much better. It was a smaller model, and it was performing much better than even some of these 10x or 20x times larger models. So that was 5.2, which was released, I think, just last month. The another important thing is, of course, the prompt. How the prompts are designed also matter in terms of how the output would be. Now, definitely one thing we know that these large language models are trained on large data, and so this is all probability based. So they are trained on the content which is on internet people have written. So a lot of it is biased, offensive. So we definitely need to make sure that we handle some of these scenarios to make them more, like responsible AI, as we call them, use them more responsibly in our applications. Prompt size and generation length are critical for the cost, so we should definitely consider these when we are designing the app. Then we need to tune the parameters like temperature. So higher the temperature is, it will have more diversity in the results. Carefully combine the fresh information. So, for example, when we have RAG, it is easy to keep on adding the data because in the vector database. And if we use something like zero shot or then it is difficult to add new information. So few shot, again, selective examples can help in adding the new information into the model. For example, the new model released last year or something will not be there in the large language model which was pre-trained using the old data. And similarly for fine tune also it is difficult to add fresh information. So depending on the use case, that if we want to have more fresh information, we need to think of the ways that we can add it easily. Now, cost is an important factor. So again, coming to that we need to use the available capacity carefully as to, how do we design prompt, how do we call it, how many times we call it, can we use a smaller model for this, larger model for this. So carefully designing for the capacity. So yes, large language models and prompting have led to a massive adaptation of NLP and NLG. So like we said, making it easy for people to start using it for different things. And another thing we are seeing is there are many options that we can go for if we want to create such applications. We should definitely imagine new use cases. For creating products which can use these capabilities. Like we see it is emergent, so maybe even nobody has thought of it, but if you think, you can try and then see that maybe it helps even in those capabilities. Then you should select the LLM based on functional as well as non-functional requirements like the time, cost, and other things. Yes, and prompt engineering and imagination are the skills to invest in. So, yeah, that's what I wanted to end the talk with.